In our demonstration today, we are going to be capturing and quantifying free radicals that are emitted from cigarettes to investigate the harmful effects of free radicals from tobacco smoke, which in addition to TARS may lead to cancer. This is the smoking apparatus that we are going to be using for the simulation. And we are going to be using a solution of N-tert-butyl phenylnitrone as the spin trapping solution to trap the free radicals from the cigarette into the solution. All right, let's add some liquid nitrogen into the dewar. Liquid nitrogen is going to be used to trap water and carbon dioxide from burning the cigarette. The free radicals will continue to travel through the tubing. And now light the cigarette and begin the demonstration. Now the cigarette is burning. The open end of the T-junction should be closed to perform puffs and open between puffs. Now we can remove the solution, which right now contains the spin-trapped radicals, and load it into the ESR tube. To get the best ESR spectrum, we are now going to deoxygenate our ESR sample solution, because oxygen dissolved in the solution of benzene is going to broaden and weaken ESR lines. Deoxygenation of the sample is best achieved by consecutive cycles of vacuum pumping and argon saturation. Now we attach our sample tube to the pump and turn the pump on. We keep our sample frozen while pumping. And switch to argon before thawing. We repeat this cycle 3 or 4 times. Now we close the valve under argon. And disconnect it from the pump. We are now going to analyze the spectra of radicals in our sample using this benchtop ESR spectrometer developed by SciQtech. This SciQtech benchtop spectrometer is rather compact in size, which is a great advantage for using it in all kinds of laboratory space. But beyond that, it has remarkable sensitivity for our ESR studies. For these reasons, we believe that this benchtop ESR spectrometer by SciQtech is the best on the market. First, we have to position the ESR tube using the template. So we take a marker, we align the middle of our sample to the room temperature height. Next, we are going to load it into the spectrometer and stop at the marker line. Now we are ready to record our spectrum. First, we're going to select the acquisition parameters, which are shown in this panel. After the acquisition parameters, now we are going to tune the spectrometer. We call the tune window, and we are going to use the auto tune feature. Now we will switch to operate mode and begin the data collection. Here is our spectrum. Now, after all scans. In order to quantify the nitroxide free radicals in our smoking simulation, we are now going to compare our signal with the known concentration of a standard nitroxide in benzene. We are going to remove the sample with our solution. And then repeat the same procedure with our standard. Here is the spectrum of our 2 millimolar TEMPO standard after double integration. The ordinate value at the plateau is proportional to the spin concentration. And here is the double integral of our spin trap solution. From their comparison, we can find the concentration of trapped radicals, which is 39 micromoles.